Ask My Instructor 3.5.41. A store manager estimates that the demand for an energy drink decreases with increasing price. The demand at price P is given by the function d of P equals 70 over P squared plus 3. If you look at the demand function, you'll see that as the price P increases, the denominator will get large fairly quickly, causing the demand to decrease rather rapidly. What we'd like to do is find the revenue function. If D cans are sold at P dollars per can, then revenue is just price times demand. So price times demand, and I take the price and just put it up in the numerator. So I have 70 times the price all over the price squared plus 3. And that is the revenue at price P. Find the marginal revenue function. Marginal revenue is a phrase that economists use. If we change the price just a little bit, what happens to the revenue? What's the little bit of extra revenue that we get for the little bit of price increase? Well, to us, that just means rate of change. So marginal revenue is the rate of change of revenue as the price changes. Now let's look at this revenue function. As price changes, the amount earned per can will change, but so will the demand. To find the rate of change, marginal revenue, we need to find R prime of P. To find R prime of P, we need the quotient rule. The derivative of the first times the second minus the first times the derivative of the second all over the second squared. Do the setup for the quotient rule. Okay, check your work on the setup. The derivative of the first times the second minus the first times the derivative of the second all over the second squared. Once you have done the setup, let's find the derivative of 70p and the derivative of p squared plus 3. When we do that, we get this expression for R prime. All right, our job now is to do a little bit of cleanup. So I'm going to take the 70 and I distribute it into the p squared plus 3. And then also I multiply 70p times 2p. And this is what I get. And notice that I have 70p squared and then I subtract 140p squared. So let's put those two together. And this is what we get for the marginal revenue function, or the rate of change. So we have the revenue function and the marginal revenue function. And we are asked to estimate the price that should be charged to maximize revenue. Well, let's first look at the revenue function. At the point where the maximum height occurs, the tangent line is horizontal, meaning R prime, the slope function, now we're viewing the marginal function as a slope function, the slope function would have to be 0 at the point of maximum revenue. So the question now is, where is the marginal revenue equal to zero? Where is it that there is no more gain to be found in revenue by increasing the price? Where does that sweet spot occur? It occurs where the marginal revenue equals zero. So where does marginal revenue equal zero? Well, if we look at the graph, it looks like it occurs about 2, but not quite at 2. So if we had to make a quick guess, we would just say 2. But we know that we can do better. So we take the revenue function and set it equal to 0. Once we set it equal to 0, we can see that the only way that this revenue function is going to equal 0 is if the numerator equals 0. So we get that if the revenue function, if the marginal revenue function equals 0, then the numerator, negative 70p squared plus 210, that numerator would have to be 0. So what we do now is just solve for p squared. Solving for p squared, we get that p squared equals 3. Take the positive root only because we're talking about price, and the price that best maximize revenue is about $1.73. We were guessing about 2, so this answer makes sense. Take care, and let me know if you have any questions.